Hi guys, welcome to another video in our long series of videos refactoring the Formatables model. Whilst you guys were away, we did do a lot of work. Got to a point where I needed some concentration without the video to see if I could get some work done quickly. So if I have a quick look at the commits, probably will see this series of commits here that weren't part of the previous video. So what we did on that short space of time, as you can see here, all these commits are deletes, removes, deletes, deletes. What I did is I went through all of the properties and classes and so on. They were actually quite trivial and got rid of them. So what I mean by that is we got to a point where the vast majority of the types that were using the locator have now been cleaned up, and now we're down to 2, and I thought we might as well just catch up with the video. So basically there are three types of information still we store here in the Formatables model. The helper related stuff, as you can see these guys here. Other assorted bits that need to be moved as well, such as test data and aspect properties and so on, which are real important bits of data. And the ones that are the target of this current video, the Odb Expander, the build files expander, and the locator. These three guys here are, well, these two guys are stopping us from getting rid of the locator at the moment. Pretty much everything else is moved. It's just these last few remnants that are causing all the trouble. And once we've done that, then we can finally look into the helpers, which I think hopefully will be slightly less complicated. Knock on wood. Okay then, so what is the problem? The problem and the reason why we couldn't get these things done quickly as part of the other refactoring, if I just quickly open up the build files expander as well as the Odb Expander. What we've done in the past is we sort of mixed and matched things a little bit. We mixed the physical model with the logical model, I guess. And this is the thing that required a bit of thinking, so we weren't really able to do this previous time. We left it for a day where we had clear head to think about this problem. So let me try to describe this situation. What's happening at the moment is that we have a nice clear cut separation between the logical model and the physical model. And the idea is that in the logical model you are in modeling space, I guess. The logical model is what you see here really. The entities are this level. These entities are a bit abstracted from the concrete technical spaces that exist in the physical models, as well as the artifacts that are populating those technical spaces. And the problem is, almost always, we have a fairly straightforward linear movement in space, in logical physical space. You start off at some kind of codec, which is a very simplified view, which is input data. You move over to logical space where you do the modeling, and from logical space you then project across multiple representations in physical space. However, these two modeling elements, which are, if I go back to logical model, so these are going to be the Odb options that we see in several of these places, the Odb targets, and we probably have in the build somewhere I'm not entirely sure if it's this guy. Let's just have a look. The build files expander. So the build files expander seems to be touching the Odb targets, which I think we've seen already. And well, but it seems quite clear that the CMake list here and the build also has the same properties. And the properties of those elements Oh, that they require knowledge of the physical world, the physical dimension. As you can see here, these are all references to directories and paths and other things like that. Which is not ideal, because finally, for the first time, we now have a reference of the physical model into the logical model. And by this, I don't really mean that we're modeling the physical model in the logical model. We've done that quite successfully already. That's fine, that's not a problem. This is still logical entities, they're just representing notions that exist in the physical model. Now what we're saying is a bit different. What we're saying is that logical entities that require information that's only available at the physical level. And so we are in a bit of a bind. But to be fair, if I just go back a little bit, let me just open up the window slightly. It's getting a bit warm here. So this is not completely a new thing, because we already had an issue with the legacy dependencies transform, which we thought was actually not going to live for too long. But so if we recall, the two transforms that we did as part of this exercise were the legacy paths transform and the legacy dependencies transform. So on the legacy path transforms, which lives in the physical model, we've computed two things: the full path, well, three things really: the full path, the relative path, and the include directives for each model element. And so that's fine. We're in physical space. We're computing things that are related to the archetype or the artifact, and it's very compatible with the way the things have been modeled. For the dependencies, we had a slightly different requirement. We needed to see the logical model in order to visualize all the relationships. And then from those relationships, we needed to take into account the projections that we had into physical space, and we needed to use those projections to compute the dependencies. So this still kind of follows the pattern of the model at the moment, the logical physical space, because what we're doing is we're sitting from logical space, and from logical space we're using a viewpoint, and that viewpoint we can see the physical space, so that's fine. However, what we have never done before is we never sat in the physical space and gazed at the logical model and updated the logical model elements. So this is the first time we need to do that. However, we can use the exact same approach that we did for these legacy transforms. We could say there's another transform here, perhaps also legacy, because we don't really know whether this is going to be the way forward. I don't think it is legacy actually. And that transform is going to have the responsibility of doing the job that both the Odb and the build files expander are doing right now. So we probably want to do something like physical to logical transform, maybe. The other problem, so this is not quite that simple. The other problem as well is that this transform requires the locator to make things even more interesting. So as you can see here, we're computing things such as the inclusion path, and this inclusion path is computed for the Odb archetype. So I guess the question one should ask is, can we not just reuse the computed inclusion path? Because at the moment, clearly, there must already be an inclusion path, right? If you think about what the legacy path transforms is doing, is it must be computing something in inclusion path. There we are. So as long as we could locate the correct archetypes, we would have access to the inclusion path. So if that's the only thing, we might get away with it. So let's have a look at the things. Oh, and also, of course, we need to make sure that our transform executes after the legacy path transforms, which I think is fine because we will have exactly the same requirements as the legacy dependencies transform, which we know already executes after. So that's not a problem. So let's continue to look at the uses of the locator here. In fact, if I just highlight this symbol, can't quite remember how to highlight the symbol. Let's just use the command. Right, here we are. So there's the locator. So inclusion path, and that's it. Although having said that, what is the ODBRP? is this guy here. And we do the parent path. Okay, that could be obtained. So okay, it looks to me as if we might get away with it, which also means that really we don't really need the logical name anymore, because the logical name was only used, I believe, to compute the path. So for this particular case, we can get away without having to know about the physical model, actually. We can have a plain ODB transform that executes after the physical transform, and it should just work. So that's not a problem. And let's try to annihilate this symbol. Now, the second case, let's see if it's similar. So we have a locator here. We make a relative path to ODB options, right? So I think this is going to be a slightly different scenario. Oh, in fact, to be honest, we have multiple uses of the locator as well. So that's L. Right, so we need to know full path to CPP header. Okay, we know already that we got that, so it's not a problem. Full path to the implementation directory. Which we don't probably store this anywhere. And what else does the locator do for us? Full path for the C++ header in types. Okay, we got that already. And then the thing we don't have, the relative path for ODB options. The reason why we don't have that is because up to now we said that ODB options were not includable, or they were not relatable. But we could compute it. I mean, they are relatable in this sense, so include source directory. Right, so ODB options are actually in the source directory rather than the include directory. And after that, the rest is easy. So we have one problem, which is the ODB options. Okay, this could have a bit of an impact, but let's keep going. Similarly here, and hopefully, right. And then on the make file, then we have to populate all of the things there for the make file. Right, so what this is telling me is that we need to capture these things as part of the path population, the legacy path population that we got already. Somehow. It's not very obvious because you have to remember that we don't have visibility of the logical elements. So for example, there'll be no easy way to put the include directory name, the source directory name, because at present no one in the physical model has that requirement. I mean, we do have Metamodel Properties, which contain, I believe, a whole lot of properties around here. I thought there was something slightly confused. I thought that we had something about source and include. Ah, here we go. Project path. Here we are. Right. So we do have the project path properties, and they do have the names of the directories, but not the full path. So okay, we could change this guy here to contain whatever it is that this guy needs. To be fair, this is the include directory and source directory name, the directory name, header file extension. Okay, right, so we got all the bits we need really, because none of these are full paths either. So that's good, we can just use that class to populate. Skip a few things. Okay, right, so there is literally one problem of this entire exercise, and that problem is we can't make a relative path to the ODB options because that's in the source directory. We don't have a way of capturing that. So what we'll do is we'll leave that one for last, because that's obviously going to be the most complicated thing. And we will just create a transform that populates pretty much everything else, I should think. And what we'll do is we'll loop through the logical model. We'll identify the model elements that we're interested in, which is object and primitive, according to this. We will locate the archetypes in the region of logical physical space. We'll obtain the path properties we'd like. We'll format these elements, and similarly for these as well. Populate the databases, though of course we need the Odb databases there too. I think that's going to be another problem. And we will update the model properties with this guy. Right, so I would call these the... we just need a good name, well, a name at least for this transform now. So the problem with this transform is that it does a physical model to logical model population of some kind. So we could call these physical to logical population transform. So it's quite clear that we're doing something really strange. Do you think? Okay. Right, let's get cracking with that then. So physical to logical population transform. Not the best of names, but the key thing is that you get the gist of what it does. And also because of that name, as soon as we see this, we will realize this is a very strange transform, which is what you want, because this is really not what we wanted to do. It's the usual engineering trade-offs. I mean, we could try to make this a completely clean design, but at the end of the day, we seem to have lost our context here. Right, so where should we put this then? Perhaps at the bottom, given that we're constrained with space. So this guy here we'll call that guy. So we have a context here, and we'll also have a model. Now, when we say entities model, really that is incorrect, because this is... well, let's have a look at what the legacy dependencies transform is asking for. Presumably that's going to be a text model. Yeah. So really, this guy is slightly lying. It means text entities transform. And so does this guy here. Right, and as I said before, we are probably going to have to rename text to logical physical, because it makes no sense really. Text is the operations we're trying to do, not the actual purpose of the model. So, and is of course a class scope. Right, there we are. So, physical to logical population transform. Hopefully that makes sense now, because we will just loop through the logical physical space, locate the entities in question, locate the archetypes, find the artifact, extract the properties that we need, populate the logical model, and away we go. So let's just then jump over to our compilation. Not quite sure what's going on here. I was saying jump where we are in compilation. So if I just generate everything, this also converts Dogen.orchestration via JSON. We have been a bit lazy, I think, creating aliases with all these targets. Not quite sure why. Our LSB Trimax symbols are the wrong size. But there you are. What was I saying? We need to have a quick look at what we generated. There we go. I'm not sure why we changed that. Let's just take that away. We forgot to clock. That would have been around 10:25 maybe. Okey-doke. So now then, let's go back to compilation. Make sure we are recording. Okay, 20 minutes into it. Hopefully this sounds a bit better than the previous video, which was actually not very good. Right, so what we just did there is nothing particularly special. Orchestration, generate new transform for physical to logical population. There we are. And then if you just jump over to that transform, so we don't really want the legacy dependencies transform, we want the... Oh, actually we do want the legacy dependencies transform. So if I just then do physical to logical population transform, it's going to be rather similar to this guy here, I think. Probably just needs context, I guess, and a bit of a commentary so that we remember. Oh, I always forget that. Populate logical elements that require information from the physical dimension. Righty, so very, very simple. And if we just take this to the other side, we have the apply here. Right, so this will now be a case of simply copying across some things from here. This is it's a shame that by the time we got all the infrastructure to make this so easy, we would have finished all the refactors. Because as you can imagine, all of this stuff that we're doing right now, all this copying and pasting, this is exactly what Dogen is designed to alleviate. The objective of Dogen is to spot patterns such as these, encode them in terms of metamodel elements, and then just automatically generate them. That is kind of the point of it. So really what we should have had by now is a transform template that gives us all of this stuff for free, and then all you needed to do is to annotate the metamodel elements correctly. But we decided to stop changing the code generator until we finished the architectural work, because otherwise there's more to refactor, as you can imagine, and that's a problem. The more you have to refactor, the harder the refactors become, so at some point you just have to have a cut. Right, so I think this is probably enough. Now we just need to find the legacy, the logical model to text model chain, which is around here somewhere, and we'll just hook in this new guy just after that. Right, so all of this is quite straightforward, so we just need a comment here, and to be fair, it doesn't really matter which order we run these two in, because we don't really rely on the dependencies transform. But there we are, we will just do this last. Update all logical elements that require data available in the physical dimension. This is not the best of comments. but there you go. Must be done after the physical model population. Okay. So it doesn't necessarily need to be last, but it must be after this guy here, because otherwise there'll be no paths. So there's a dependency there. Oh, okay, so it seems like the tree max is also struggling in terms of size for some reason. There you are. So if we, sorry, not what I meant to do, if we go to 5 and try to run the test again. So this is just going to basically, oh, I forgot to do the I/O for it. So I think we just need the text. Population. Right, so we just need some guy here. Right, so let's try again. Hopefully this will now allow us to dump the text model over to the tracing. Nothing should break because we are not actually doing any work just yet. Okey doke. Good enough to commit, really. So we could say something like hook in new physical to logical population transform. And now then we can start to think about what the transform actually does. So for this we need to go back to our two transforms that we're trying to copy across. So we'll start with the build files because I reckon this is the easiest. Now this is gone for an element visitor. I think we can get away with the same, I think. So let's just follow the same pattern here. Right, so take one of these guys. And then probably will need all of this, I suspect. I suspect we also will need, well, to be honest, I reckon we could probably copy this whole thing as a starting point. We just need to replace these calls to locator, I think. Bit of luck. So if I just put this here, it's going to be a lot of errors, of course. And then if I then say, I'm not sure what an Odb Targets factory is. It's a visitor, so it's all good. And then we just need to figure out the equivalent machinery in text model terms. Right, now then, there's going to be a lot of problems. So let's just think about this for a second. First, let's just do the easy things out here, such as these guys. Probably will need almost all of these guys, if I'm honest. Element visitor we already have. So I suspect we need pretty much all of this. The logical model. Then we won't need traits. We won't need the expansion error, but we need the equivalent. Let's just go back to the dependencies transform. There will be an exception somewhere. Not that exception, this guy. We're just mapping these to the new types. And that is about it. Now then, let's look at the errors we're getting. So, this guy is requiring the model. I wonder why we need the model. Well, we certainly can't have a locator, so that's not gonna work. We have a logical model name, not entirely sure why, but and let's try to understand what the model is doing. Oh, here we are. So we're taking the model name to compute. Now I don't think text models have a model name, so that's going to be another interesting thing. And in here we're going to be doing the actual work. So that, okay, we know what we need to do there. Just need to locate the right things in the region. Now, so we need to understand. So similar to what we've done before, is we are processing a region of space. So this has to be slightly different from what it was before, because your the view we have here is of the logical model. So we're going to be in a logical model element. These guys are going to be calling generate targets, presumably. Yeah, as you can see here, we are visiting each logical model element, and for each of these we call generate targets. But clearly there's a problem, which is we need to also know the region in logical physical space in order for this to work. Without the region in logical physical space, you can't obtain the properties that are in the physical parts. And so we had exactly this problem when we were doing the legacy dependencies transform. Let's have a look. Yeah, you can see here in the legacy dependencies transform, we had a region processor. And what the region processor did is it processed a region at a time. So you supply it with a region, and then it knows where to query. But that does mean then that you can't visit the entire model in one go. You must visit a region at a time, which is fine. We just need to use the same logic as we did here, which is loop through the regions, and then each region gets to visit, and then we can then do whatever querying is necessary. So whereas here we were attempting to actually create targets factory for the whole thing, so that's not going to work. Okay, so let's just try then to see how we can fix this. Bit hackery required here, but so we're going to need something like this. And well, to be fair, for whatever reason we put these using below. Not sure why we are saying Dogen. Yep. Right, so then we need to say, please supply me with a region. Now, why do we need the whole model, I wonder? Because we are actually keeping the whole model, not just the name. Ah, because of the databases. And I think that is it. Okay, we need, so before we can go any further, we need to understand what these Odb databases are all about. So, model.odb databases. This is a Formatables model. So we need to understand in text.cpp what are the Odb databases. Not obvious to me why we need Odb databases, because that's specific to Odb. You would have thought we'd have some kind of logical model, non-Odb specific view of databases. Where is the model? There's the formatable. Right, here we are. Ah, it's merely a list of strings. Now I'm very curious as to what these Odb databases are. let's open up an RG window here somewhere. So if I just go back to projects perhaps, IRG on CPP, let's have a look. Right, so the adapter, which we haven't touched just yet, is populating the Odb databases. Now, what I would like to know is how exactly is this happening. So we are going to the model properties, we're looking for the database systems, and well, we're not really doing very much here really. Right, so we should probably try to understand how these OP, whatever these things are. Right, okay, so the ORM properties from the logical model are being used to generate the databases. Right, cool. Not to worry. What we need to do then is, in our first stage is, we need to do exactly the same thing. So if I just take this guy here and say so if we just create a method here, private perhaps, and let's just call this make Odb databases. I'll probably need the text model. Probably don't need the entirety of the text model, of course, but it should be static. Right, so what we'll do with this is getting a bit messy, but we get the gist of it. Job of this chapter is going to be to locate these properties and create them. So if we just go up to the adapter will access the properties from the text model, presumably. From the logical model, yeah. So interestingly enough, we also have this Odb SQL name case. I'm sure this will be used somewhere. Maybe not here, but on the next one. But anyway, let's just confuse one issue at a time. So we'll just have one big fat function. I think we don't really need all these little functions. So if we don't have that, then return R, so it'll be empty. And then we do have it, so ORM properties, then well, we don't really want that, so we want make databases bit, and that's just going to be presumably just something like op dot database systems, push back common, and then for each of the interestingly enough, let's just have a very careful look as to what this thing is. Yeah, just OP, isn't it? Why is it called ORM properties, model properties? Well, there we are. Anyway, naming is not the best here, but doesn't really matter. And then to database DS. Now we just have to make sure we understand what this to database is doing. And we'll do something like this. So we will need this guy. We'll switch, and then we will push back into these. So as you can see here, all we're doing is we're inlining several of the methods that were scattered in the adapter. Then we're going to throw if there's a problem. And then we get rid of all of this. And then we return the database systems. So basically a string conversion of the database. Now we'll just need to grab a few of these things. So we'll need these guys, definitely. Oh, of course, remember this is no longer a return, so we need to remember not to continue. Right, now then, so if we go to the strings and say, put a few of these here, and then if we look for invalid database system, put this guy here, and then finally we will need a few includes. We will need a database system IO, probably a logical thing, I guess. Yep. And we will need that might be it, I should think. So at this point we now have the Odb databases, and we can start off by saying, well, what we probably will do is let's just start by committing out all of this, because we really need to have some compiling code, otherwise it gets confusing. Const auto dbs make databases, and that is made using a model. Okay. Now then, Emacs is not liking the errors. Now, what we need to do is we need to replace, right, as we did before with commenting everything out down there. Let's do something similar, because we're only focusing on the very first factory. There's no point in worrying about everything else. So let's just locate all of this stuff, comment this region. Let's get to a point where the errors are more or less under control. Right, so then what we got, so we now know we don't need the model, but we can just basically say something like const blah 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 databases, and we have a model name, so that looks good. Here we will just have our generate targets, types we're visiting, a result. So where we asked for a model, we will just take the databases. Whatever this target name is, I mean, we don't really need this to be by reference, so it could be a copy. And here we are. So if I just say this is databases, the model name. Right, so there is no such thing as a model, so we construct the model name here on the fly. We don't seem to like databases. Ah, okay, right. This is because we keep faffing around with the order of things. So let's just try to fix the order. very nice to have all this stuff happening here in the constructor. Quite confusing, but once you get the hang of it. Right, so what we're doing then, we are constructing the target name by joining the model name, the location. Now I think, really, given we're going to construct this many times, we should just supply a target name, really. So here we can just do something like const auto target name, which is Odb plus well, I suspect we could do something like const auto model module, boost join all location with the model modules, but presumably need a separator too, which makes me think that perhaps he wants const auto model modules, and then we just want that to be this plus a separator, which now makes it a little bit more convenient. And now we can basically say, so that's going to be something like this. The target name is basically Odb plus underscore. I'm not quite sure exactly target name means, but we don't really want to worry ourselves with all of that stuff right now. We just want to make sure we do something equivalent to whatever it is that we are doing somewhere else. So here we want to string, and that's just the target name. And you can see Emacs is getting a little bit upset for some reason. We already have a target name there, and we just change this guy to be the target name. And then we just need copy and paste job. Target name is where the target name is, and this now looks a lot more sensible. So, righty. Now you can see it suddenly became a lot more sensible. What we need to do though is we need to go back to the legacy dependencies and talking about regions. So we need a logical physical region here too. So this guy is going to have the databases, the target name, and to be fair, we probably should think in terms of logic. The target name makes more sense to come first, then the databases, then the region. We must make sure we put the region that we're using for the region. This guy here will have the region here, the reference, that's fine. And then we just need to wrap things up here. So that's kind of how typical refactoring happens around here in Dogen. We just faff around the code a little bit, mold it into shape until it starts to make sense. A bit different from, I guess, what we do in a professional job, but interesting nonetheless. Now, the other thing we have to take into account as well is we are generating the Odb targets. As a result, right, we just have to be slightly careful here, because remember, we are now looping through regions, and the Odb targets that we're generating here are actually not on a region basis. They are all the overall Odb targets. So we don't really want to be populating the target name every 5 seconds, because we know already what these things are. So what we probably want to be doing instead is we probably want to be saying something like this, Odb targets, OTS maybe, and then OTS dot the target name, or whatever we're doing in the constructor. If you see what I mean. and the target name is all this stuff. Right, so we've initialized the target, and then instead of, so now life becomes a bit easier, because now what we're saying is just take the Odb targets. Right, so there's a few problems here. So what we'll say is that the region is constant, because we don't really envision having to touch the region itself. The targets is not constant, and what we'll do is we'll remember the targets. Well, we already were remembering the target. It was called result, so that's good. We don't need target name, and we don't really need to visualize the result because, well, we're populating it from the outside world. Now then, we will receive the databases as well as the region plus the ODS. The targets will be right, so now this should make a bit more sense, I think. And then the result is basically the ODS. And now hopefully we are converging to something sensible. Right, this guy then will be responsible for looping through regions. Well, not looping through regions, but processing a region, one region at a time. It also tries to keep track of the global Odb targets. And it will just populate a little bit of the Odb targets. I mean, to be completely honest, right, this is where design comes into play. Now you could have this global object that you're kind of polluting as you go along. Another way to think about this is to say, actually, what is this guy's doing? Well, it is taking each of the targets that we are creating I mean, to be honest, I'm just going to do this the dirty way. The right way to do this would have been not to have mutable state and to just keep track of the common Odb options in the targets. But it's easier just for now to do it this way, because otherwise it will take us a while. What we really want to do is to prove this thing works. So it's always best to do your refactors one at a time, not to confuse too many things in one go. Now then, okay, I think this is looking okay. So we go here, we have some kind of notion of an Odb targets. We need a target name, which we lost. So we need to reinstate the target name. But this time we will just take whatever that is. Bit haphazard this refactoring, to be honest, but some of these things require concentration. So I wonder if it would not be slightly more readable to just say, let's have a lot of commas here. Yeah, that seems a bit better. So there we are. Now we have a target name, separator, whatever that is, and dot simple. Okie doke. So now there is no locator. Now this is where we need to go into the region, right? So how do we go into the region? Let's have a look what this guy does. So what this guy is doing is basically saying loop through all the different artifacts. Now we want to do something slightly. Seems like we're breaking things here. What we want to do is something slightly different. This guy is to looping through the region. We don't need to loop through the region. What we really want is just to say something like, what is a class header archetype? So that's going to be something like mas.cpp.types.class header. This guy here. So we want to do something like, take one of these, go to the region, find him, so find this guy, and of course we probably don't want to be carrying around something as big as this, so perhaps something like const auto artifacts by archetype makes it easier to read. If we didn't find it, we have a problem. Not that problem, but this problem. Okay. Let's copy this guy here. We probably need lexical cast. I will reactivate not sure if that's the right thing, but something like that. We'll reactivate errors in a second. LSP seems to be a bit out of touch with what we're doing. But there's so many errors, this is not going to be very helpful anyway. So, this is something like a missing archetype. And that's going to be CHArch, presumably. Right, so we are looking for something in the physical space. If we can't find it, there's a problem. If we can find it, we need the path. And that's going to be something like presumably an artifact, I guess. Okay, now we're getting to a point now, I think, where we need some LSP help. Because we can't see the type system anymore. So let's just do a direct jump. See what LSP thinks. I mean, there are a lot of errors at the moment, so it's not too bad. We're getting somewhere. So, see, as you can see, it's much easier when we are able to see the errors. I think we'll probably need to comment out some of this stuff because it's just overwhelming LSP, I think. What we'll do is we'll just comment as we go along. We just need to get to a point where we have a smallish number of errors that are dealable. See, this is the classic case where if you've got the time, you so for example, let's imagine I can do something like this, right? Const string x and then close, and now let's just say name last keyboard macro. Let's call these I don't know, MC/add string. So next time you need to add a string, you could actually just say add string this is the thing with Emacs. I mean, you really have to spend the time to optimize your Emacs workflow, because otherwise Emacs doesn't really add much value as an editor. Emacs is very powerful, but only if you start using these cool features. Right, so we're in a region apparently. What can we do with the region? Ah, okay, we have to go into the physical region, and then we can see that. Now, why does it think that there is no find? Oh yes, the reason why, of course, is because we need to create the Pmid for this. So let's just create the Pmid here. Did we bother to? No, we didn't. So we will have to find. Right. So this is a physical, not a metaphysical, but well, we can use that as a starting point. So we need a physical ID, I think. If I'm right. And then we just need to create the physical ID here. And I think we can do something as simple as this. Right? So we created a physical ID. Invalid operands to expression. Right, so clearly... Actually, I'm not entirely sure why that doesn't work. I would have thought you could do physical ID like that, so let's have a look at why not. Here we are. You should be able to do a physical ID via a string. That we are, actually. This is going a bit crazy. LSP is really struggling at the moment. Right, now then, let's just figure out what the artifacts by archetype is all about. Now, we need to look at a region in physical space. Oh, physical meta ID. Yes, which is correct, sorry. Physical meta ID because it's an archetype, not an artifact, so that's absolutely correct. This is what I mean about concentration. This is very easy when you're just focusing rather than talking and coding at the same time. Right, so clearly that's a physical meta ID because we're referring to an archetype, not an artifact. That will now work. Now we need something like value here. That's fine. And now then, if we did manage to obtain an archetype, an artifact should I say, which will take us all the way here, now we just need to think, how do we get into these path properties, right? We probably just need the path properties inclusion path, I think. So it's going to be something like this, path. We need to remember that this is a pointer. And probably now we can't see the artifact. Now, with a bit of luck, we need to then find the inclusion path. And there we are. So that's now equivalent to all of this without the locator. And what we really want is the parent path of that. So here we are. However, interestingly enough, notice that there was an Odb FP rather than... Yes, so we have to be very careful when we replace these functions to replace them correctly. So make full path for C++ header. Okay, that's a problem. And this is always the kind of problems you're going to end up having here. This is not a relative path, it's a full path. Slightly annoying. Now, how do we address this problem? I mean, we could have a relative path to the header. But so to be honest, I mean, I wonder what if all we're trying to say is make full path to C++ header, don't we really just mean the file path? I think we do. So that being the case, a bit of noise downstairs, double check everything's fine. Okay, nothing major happening. So 1 hour and 5 minutes. So yeah, I think, I'm not sure, but I think we can replace all these complications and say, actually that's just basically the file path, and we just want the directory where that file is in, I think. Now, of course, the errors will tell us if this is right or wrong. And then the source directory, right, that's going to be in a completely different location, right? We need to get that as a parameter, I think. Yeah, I think for that one we need somebody to give us the source directory. That's going to be in the MMPs, and we haven't quite got the MMPs just yet. So let's see if we can get a model name. So if I go to the logical model, ask for its name. This could be something like cost auto model name. Okay, and which we could abbreviate to MN because everyone knows what that means. Which makes me think that perhaps we don't need all of this stuff. We can just go straight to the model name. Nobody else is asking for anything. Right, so just want to bring these errors down to the absolute minimum to get a good view of where we are. Okay, so now then, if you remember, we had this MMPs around here, and the ORM properties, and the MMPs no, actually we're not using the MMPs at all here, so that's not a problem. What we'll do is we need to access the physical model, obtain the MMPs, and then supply the MMPs as a parameter to the new visitor that we're trying to make. We don't probably need the whole of our MMPs, if we remember. It's only the project path properties really. So if I just say around here, now I'm just going to be lazy again and just do a using here. Something like this. So we have the PPPs. I don't know why I said logical, should have been physical. Right, there we are. So the project path properties will contain the bits that we need just below the region. Sorry, I'm going to have to go for a really long name here, but not a lot of options. So if I take the PPPs, that doesn't fit. That does fit. And then if I just say something like just after the region. Right, so now then, I've got the project path properties. When you asked me for the source directory, perhaps I can say something like but of course this is the source directory name, which is interesting but not quite what we want. We need the full path to the implementation directory. Now the full path to implementation directory will require a lot more knowledge. This is a little bit tricky really. Now we have the output directory path. We also have a file path. Well, between all these paths, something should give us the path we're looking for. I should think. let's have a look at what the locator makes of this. So if I just look for legacy path, something like this, that's going to contain the locator inside. That's going to have a method we probably don't use anymore. Oh, we do actually. Right, so as you can see here, the full path to the implementation directory. What is that then? Is the project path, and then it takes into account the backend. It is actually non-trivial computation here. We need to take into account the project path properties. We need to take into account the C# project path or the C++ project path. These things were computed a long time ago, and they take into account the output directory path and the backend ID. So this is actually a computed thing. We really can't get away with it. So, however, we do have the Metamodel Properties. The Metamodel Properties have a file path so this is just a little bit tricky because we need to resolve things that were actually quite straightforward before, now become a little bit more complicated. We could say that this is a backend property. The backend property will give us a full path to the backend, but that's not quite what we're looking for. We need to know. So let's have a look at what we were looking for before. In order to know the implementation directory, this is really the part path, which sadly we don't have yet because we haven't implemented parts just yet. So what is the quick hack for this? I think the quick hack for this is probably to have a property in the project path. So we already have a source directory name. We should have source full path, source directory full path maybe. Which is populated by this guy here. And then we just have to make sure that the model. Yeah, so the problem at the moment is this. It could be C# or it could be C++. So the new data model, of course, I mean, just take a step back here. Once we move to the new world, it's going to take us a while, but at some point we'll get there. We already have a model that takes into account all these nuances. And that's the idea that projects have got parts, backends, and so on, right? So we can generate a path that is actually exactly the path that we're looking for right now. However, we're in between the new world and the old world, and we just need a better way to do this than it was before, but not the full-blown way that requires all of the part infrastructure, because that's exactly what we're trying to do. So it's kind of like we're going in a vicious circle at the moment. So we just need to break the circle by finding some very simple way of getting access to this path. And that very simple way, so the first thing to do is to just try to understand how many full paths is this guy asking for. So full paths to C++ header, I think that's fine. And then the implementation directory, and that's it. So really we just need one directory here. And given there is no notion of parts, the only fear though is that if we have a model that is being expanded or projected to both C++ and C# technical spaces, then I think we'll end up with 2 paths rather than 1. So let's see if we remember what we're doing here. No, because the model has only one technical space, so presumably that means it has to have a single path. So there's only one projection to the physical space, which makes sense, right? You can only project one region of the physical space at a time. Right, so then, let's do that hack then. Let's just call these the implementation directory. So, I mean, as you can see here, we don't particularly care about names. So if we do something like this, and that becomes a boost file system path, and maybe we need a bit of space, not too much, and okay. Right, so now this guy here will contain the implementation directory full path. Now I don't think you can compile just yet, but we're not far from it, so what we'll do is we will just ask this guy quite nicely to go away, and then if I just do generate everything, we just need a conversion for the physical model. Right, so this guy now is going to give us the path property that we wanted. Let's make sure we don't touch anything else. And we'll just run the tests. Hopefully that's not going to cause any problems. So the idea here is that we're going to have just that one thing populated, and we populate it with exactly the value we need. And by luck, I think might do the right thing. And in the new world we'll be fine, because in the new world we'll be asking for the different parts. We look for specific parts. I mean, it's not going to be trivial, to be honest, because of course we still have the whole craziness of how it is that we're going to be able to map the physical structure, because remember, in the new world the physical structure is completely generic. We don't really know what artifacts and archetypes and stuff. We're not going to be binding directly to archetypes like we're doing here. If you look at what we're doing things like binding physically, specifically this archetype to this, well, we know specifically what we're looking for. In the new world you can't actually do that, because everything is data. It's data driven. So you'd have to find a way to say this guy needs the path that's given by, you need some kind of way of data mapping this binding. And that's why I think it's so hard to do the new world without some intermediate steps, because it really requires you to think in quite an abstract way. Okay, we seem to be having an error. Okay, so I think the problem is we probably, as a constructor, nobody should be really talking about this. Ah, yeah. Oh no, it's commented out, so not clear why we're trying to instantiate it. Ah, the targets factory is kicking in. Okay. Targets factory. I didn't think we were instantiating that time. Sorry, let's just look at this slightly more carefully. So it seems like we're instantiating the constructor. The constructor is getting a little bit confused. I think the easiest thing to get away with this is to say, well, don't bother defining the constructor for now. Not quite what I meant to do. Okay. No, that's bad. didn't think we were doing anything special here, but there we are. Let's just, we really don't want to be doing anything at the moment. We just want to commit the new thing we just got. Should not be causing any errors. That change. Right, as expected. Right, so as you can see, none of the hackery that we're doing in the transform is going in. It's just the path properties change. So physical adds full path to implementation directory to path properties. Okay, and now what we need to do is you need to go to that dependency guy. There should be a path property somewhere. Project path properties. So we have been treating this as const for the purposes of the locator. Now we have a slight problem, I think. The project path properties are being supplied to us as part of the PM. The PM is const. Well, I wonder if we create a locator somewhere around here. Oh, we do. And where is the PM? Don't seem to be doing much with the PM. I wonder, in our spirit of hackery, if we can do something like m not physical. Clear what kind of model we got here. I thought it's a text model, but clearly not. We have a physical model. Okay. Right, so what we're going wrong, I think, is that we are looking for, yes, the Metamodel properties. That's the problem. That's the confusing thing, is that the model has Metamodel properties, so I always get a bit lost here. Path properties. Okay, so what we need to do then is we need to say auto by reference path properties. Presumably these are not used anywhere else. And then we need to then say something like ppp dot implementation directory for path, and that then becomes the l dot. Okay, so interestingly enough, we seem to whoops. Well, actually, let's just look at what the locator was doing before. Which is this guy here. We just need this. Okay, so with a bit of luck. So let's just say that this is the first bit of work that we do in this function, which is obtain the full path to the implementation directory and update the physical model with it. Okay. Again, this should not cause any problems whatsoever. And so I'm afraid we're going to have to be continuing to do hacks like this. So we're doing for time. Now we're 24. And what clock time is it? 12 o'clock already. Okay, so that worked. So what we're going to do is we're just going to quickly see if we can get this thing to compile. don't know why we're crashing at the moment, so I think that's all fine. So that's all fine as well. It's not very clear is why we can't link at the moment. Right, there we are. So we can't link. It's apparently missing a vtable. Now what could... Well, I wonder if the problem is this is an element view, so maybe it's just some kind of weird C++ thing that just because we are inheriting and we've defined a few methods here, now that the compiler is expecting us to actually implement those methods. Okay, so that's fine. What we're going to do is we know for sure that what we did to the legacy path transforms didn't break anything, so we can then just say something like populate in legacy. Oops, we could spell. So something like this. And I think we probably, unfortunately, have to call it a video for now. So we haven't actually achieved very much. But what we've done is we started to move one of the transforms to the new world, well, to the legacy world. So this is the in-between world, I guess. And we now know what the requirements are in terms of things that we need to bring in terms of the path. So we will just do this one for now for this video. I might have to speed things up a little bit without recording because this requires a little bit of concentration. And once we've got that transform, then hopefully we can test just that one transform in isolation. And then perhaps we'll come back to the videos. Okay, thanks for watching.